हाँ 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 वो है ये पास है Okay, students. So let's start the. Very good morning, all of you. So last time, what we did last time, we draw a curve of last time we draw a curve of moisture content versus time, and we also draw a rate of drying versus moisture content. We draw these two graph, and based on this in this graph there are two sections. One section will be the constant rate period and another section will be the falling rate period. So two sections we see, constant rate period and falling rate period. So these two sections we see. Now what we have to do, we have to calculate the example based on this graph. So ultimately we have to calculate the example of the drying. So to calculate the example of drying, we require the equation. To calculate the example of drying, we require the equations. So right now then we start deriving the equation for constant rate of drying, constant rate period, then we solve the example of the falling rate period. So first we have to derive the equation for the constant rate of drying, and then we have to derive the equation for the falling rate period. So So and for constant rate period, we also derived it. So as you see in your screen, for constant rate period, n is equal to, we said, minus weight of solid divided by area drying dx divided by dt. If I rearrange this equation, because ultimately we require the moisture content versus time. So dt is one-sided, dx at one-sided. So dt 0 to t minus ws divided by a. So here n is a constant term. N rate of drying for constant rate period is fixed. So nc will be taken out from the integrations, and if I do the integrations, so finally we get P is equal to weight of solid divided by area x1 minus x2 divided by n, means rate of drying. So now this is for constant rate period. Now we have to for the falling rate period. So we have to derive today for the falling rate period. Now we have to derive it for falling rate period. Now in falling rate period, there are two cases. In falling rate period, there are two cases. So let me draw the graph again, and then I explain you what are the two cases. So this one graph, this one graph. So constant rate period from here to xc we derived it. Now this a falling part we have to see. So there are two cases for this falling part. The first case is the general case. And second will be the special case. First one will be the general case, second one will be the special case. Now if general case will be there, if general case will be there, then here is a rate of drying n. Then so for general case, what we have to do, we have to draw a graph of it. We have to draw a graph. So drawing, if for general case, let me write down for general case. How to find out the answer if we have a general case for falling rate period. This is applicable for falling rate period. So if we have a general case, then what we have to take, draw a graph. One divided by n versus moisture content x. We have to draw a graph 1 divided by n versus x, and then one divided by n versus x, and then for examples I am getting this type of curve. Then moisture content 1 for xc, another final moisture content. Then we take the area under the curve. Once we have an area under the curve, then based on it, we can find out the time required for the falling rate period. So ultimately, we require the time required for the drying conditions. So by this way, we can draw it. So now how to find out area under the curve? For example, how to find out area under the curve? So area under the curve, we can find out here if we have a graph and we have a number of boxes are there. If we have a graph, then we have a number of boxes are there. So we have to calculate the how many boxes are there under the curve. So number of boxes multiply by x-axis multiply by y-axis. So we have to calculate number of boxes multiply by x-axis multiply by y-axis. So if we then area under the curve we find out. Once we know the area under the curve, we can calculate the time required for the drawing. So this is for general case. We also calculate one example, and based on one example, you will understand this concept very well. Now, second case will be the special case. So now for special case, we have a special case like what we have to do here for special case. We have to say that we have a special case like this graph is linear in nature. For special case for falling rate period, you have to assume that we have to say that n is linear with x. Rate of drying is linear versus x for this region, for this whole region. This is a linear case. N is linear with x. So if it is linear in nature, then it follows the straight line. To follow the straight line, it means we have to say that n is equal to mx plus b. If it is follow linear, so n changes with x changes. So n relation with n in x, n is equal to mx plus b, where m is equal to slope and b is a constant. Where m is equal to slope and b is equal to constant. Then, so what we have to do? Then we have to do the integration. What we have to integrations? Here we take n is equal to. Here I have to take t is equal to ws divided by a. x2 to x1 dx divided by, here we have n, so instead of n what we have to take mx plus b. So we have one moisture content, we have another moisture content, we integrated two moisture content, dx divided by mx plus b. So in special case where n is equal to linear, so if I do the integration, then what happens? ws divided by a ln integration mx1 plus b divided by mx2 plus b. Now we have n1 is equal to mx1 plus b n2 is equal to mx2 plus b n. We have a slope m is equal to n1 minus n2 divided by x1 minus x2. So we have a n1 is equal to mx1 plus b, n2 is equal to, we take mx2 plus b, and we take slope is equal to n1 minus n2 divided by x1 minus x2. So one side to do is t is equal to ws divided by a. Here it's ma, huh? It's mistake from my side. ws divided by ma ln mx1 plus b plus mx2 plus b. Now instead of n we have to write down n1 minus n2, x1 minus x2. So x1 minus x2 divided by n1 minus n2 ln n1 divided by n2. Then so we can rearrange this one, and we can also write down like this one: ws divided by a x1 minus x2 divided by here n1 minus n2 divided by ln n1 divided by n2. So we can write down like this also: ws divided by a x1 minus x2 divided by a sorry it's n logarithmic mean rate drive. Here nlm is equal to then so this is the write down for the special case where we have to say it's a falling rate period is linear in nature. This is also a correct one. It's also a correct one. This is also a correct one. All this is also a correct one. All are the correct. So according to the example, we have to use this one. So this is only one for the constant rate period equation, one for the falling rate period. Okay, done. So now we have to calculate the example based on this concept for constant rate period as well as falling rate period. So just 1 minute, I paste example here. Once we calculate one example, then you will clear with this concept. હું લેતો લેક્ચર પૂરું થઈ just 1 minute, students. Okay, students, just let me paste one graph, and based on this graph, we have to calculate the example. Okay, one graph is on your screen. This is the graph. This is the graph. Now, based on this, we have to calculate the example. So the graph is the batch of a solid. The example is a batch of a solid for drying. Graph is given. So we have a constant rate period, we have falling rate period, we have a different moisture content. We have a different moisture content. Now, drying from 25%, 25 to 6% moisture. Maru karja mummy. Drying from 25 to 6% moisture. Initially, weight of solid is Initially weight of solid is 160 kg. Now value of SS divided by WS divided by A is equal to 40. Then this is the given. It means kg of dry weight per kg of area. The kg of area. Okay, and ultimately time required for the dry. Ultimately, we have to find out the time required for constant and falling rate dry. So now let's understand one more time example. So we have to follow this graph. Graph is given to you and we have to follow this graph. Now once you follow this graph, there three sections are given. The starting of constant rate period from B to C. So we have to follow the XC. The finish of the constant rate period is up to 0.2. Now the falling rate period starting from 0.2 to the ultimately how much we have to end within the 6%. So we have to starting from 25% drying. You have to convert percentage into the numerical. Then up to this we have to calculate for constant rate period how much time is required. Then from constant rate period up to the 6% moisture, how much time is required. WS per A is given 40 and we require uh, 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 constant rate period as well as uh, falling rate period. So now if I convert 25%, so X1 will be the 25%. So 25% means 0.25 for 1 minus 0.25. It means what we take, we have to convert this moisture content into the kg of moisture into kg of dry air. So total we have a 1, dry air having 1. In the dry air we have a 25% moisture. So 25% it means this is the kg of moisture divide by how much now dry air is there. So total 1 will be 1 minus 0.25. It means dry air. So once I sorry here it's not like this. Here it's like this. 25 multiplied by 0.25 multiplied by 1 minus 0.25. It means here we find out kg of moisture per kg of dry air. So 0.25 multiplied by 1 minus 0.25, it means 0.336. So we have to starting from 0.333. So it's 0.3, 0.35, and here 0.33 we have to consider. Now, up to what we have to dry? Up to we have to dry it for the 6% moisture. It means x2 is equal to 6%, 0.06 Here it is a divide by it's above one is correct. 0.06 divide 1 minus 0.06. It means that we have to find up to the uh, 0.064. So we have to dry it from kg 0.33 kg moisture per kg of dry air. Here kg of moisture per kg of dry air. So here 0.064. So here 0.1. So here nearly up to this one. Here is 0.5. X star is 0.5. Sorry, 0.05. So nearly up to 0.06 we have to do. So 0.033 to consider as a up to 0.06. So now for constant rate period, we have to starting from 0.33 and moisture content is equal to 0.2. So if I take a constant rate period, then T is equal to Ws divided by A, x1 minus xc. Xc means up to the constant rate period, divided by Nc. Then okay. So now Ws divided by A we have. Ws divided by A we have how much? 40 divided by 1. X1 we have how much? X1 0.33, 25%. Up to constant rate period is how much? Up to constant rate period is 0.200. So here as I see in the screen, here we have 0.33. Starting constant rate period how much? Up to 0.2. Okay. From that, what is the value of NC? So we have to find out the value of NC from the graph. Here we have to drawing here. What will be the value of NC is here. Then we have to here the constant rate period. What is the value of N? That we have to put down here. So if I put the value of NC, the value of NC will be the 0.30 multiplied by 10 raised to minus 3. So if I do this, then we have a time for the 17,730 seconds. 7,730 seconds. And if I don't take minus 3, then whatever we have to take is in minute. So whatever take they are in different unit. So for the unit purpose, we multiply it by 10 raised to minus 3. Here we have yes we take 10 raised to 3. Here we have 10 raised to 3. So ultimately, if I multiply by 1 divided by n, is 10. So 17,730 seconds is the answer. Now we have to calculate for the falling rate period. Now we have to calculate for the falling rate period. So falling rate period, what we have to do? We have to draw a curve. So we have to drawing a curve. From where drawing a curve? 1 divided by n versus x. So starting from 0.2 to 0.6, we have to take different point. We have to take this 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 point. So different points we have to consider, and based on it, we have n value. We have x value. So what we have to do? We have a different value of x with different value of n. So I am writing down different value of x versus different value of n. So x is 0.20 at that time according to graph, n is the 0.300. If x will be the 0.18, then we have a 0.266. If x will be the 0.16 and 0.239. So now we have a different value of x versus different value of n. And here it tends to 3. Here in n multiplied by 10 raised to 3. So we have 1 divided by n. It means we have multiplied by 10 raised to minus 3. So if I do 1 divided by n, then 3.33, 3.76, 4.18, 4.80, 5.55, 6.67, 10.3, 14.3, 23.3, and 40.0. So now we have to draw a graph. Once I draw a graph, 1 divided by n versus x. You have to draw a graph 1 divided by n versus x. So let me draw a graph 1 divided by n versus x in Excel. So just 1 minute, I open the Excel. So as you here in Excel, we have a x. Let's draw a graph, and using graph we can know how to calculate it. So x value I write it down 0.20, 0.18, 0.16, square, 10, 0.09, 0.08, 0.07, 0.064. So n value we have 0.300. So 1 divided by n. So if I write down the different value of n, so we have 0.3, 0.0266. So first I introduce drawing a graph 1 divided by n, selected data, remove, I have to add the data, x1, and here this one, okay. So if I do it, then 0.06266, 0.0239, here I take a wrong value. Here I could take this one. So 0.0239, 0.208, then 0.180, 0.150, 0.097, 0.070, 0.043, 0.025. Then so these are the graph we get 1 divided by n versus x from 0.2 to 0.06. So now we have a 1 divided by n versus x. So let me make a very good graph. Chart table, axis table, 1 divided by n versus x. Versus x. Okay. Now we make a one chart title we get 1 divided by n versus x graph. Then we make a very good graph one. Okay, this one is okay. Let's take a format of axis. We take from 0.05 okay. Now I copy here, I paste it here. Yes, we are getting a very good curve. Now we have to take a limit. Take a limit from 0.20. So here will be the 0.20. From 0.20 to 0.064. So here we have 1 point here. 0.064. So here we have to take this one. So now we have to draw a line in between it. Now we have to draw a line in between it. From here to here. How many boxes are there? One box, another box, third box, fourth, fifth, sixth. Here combined 7, 8, 1, 1 and 1, 9, 1, 1, 1. Combine it's 10. So a number of boxes is equal to 10. Multiply by what will be the x-axis? It's also a 10. Multiply by what will be the this axis? 0.02. So how much? 10, 10, 100. 100 multiplied by 10 multiplied by 10 multiplied by 0.02. It's a 2 multiplied by 10 raised to 3 second. Here 1 divided by n multiplied by 10 raised to 3. So here 10 raised to 3 seconds. So these are the 2 multiplied by 10 raised to 3 second in the time required for drying for the falling rate period. So entire rate period falling T will be the constant rate period plus falling rate period. So constant rate period time is 17,730 seconds. 17,730 multiplied by plus 2120. So 120, 2000 plus 17,730. It means 19,730 seconds time required for drying for 25% to 6% drying. So this is the example. Now anything from your side? Okay, sorry, board is not visible now. Okay. So now as you see the graph is here. Now your board is visible. Now board is visible. Okay, so now we here is a total graph. We take number of boxes 1, 2, 3, 4, 5, 6, 7. Combined we take 8. Here combined we take 9, and 1, 2, 3 combined we take 10. So it's an approximation. It's not an exact 10, but nearly it's a 10. So 10 multiplied by now x-axis 10 multiplied by here difference between 0.02 between the one. So one box here, one box. So 10 multiplied by 10 multiplied by 0.02. So 1 divided by n is raised to, we take 10 raised to 3. So 2 multiplied by 10 raised to 3 second will be the total time required for falling rate period. Now if I do the total time, so constant time plus falling time. Constant time we take 17,730 plus falling time we take 2 multiplied by 10 raised to 3. And so total time will be 19,736. So moisture content from 25% to 6%. So we take one example. This is the book example is given. Now what we'll do, we stop here, and tomorrow, students, please listen carefully. Tomorrow we have two lectures. So we'll start this lecture from 7:45, and we'll take one lecture, then we have a break, then we take another lecture. So we finish the lecture in morning part from 7:45 to 9:45. We'll finish the lecture from 7:45 to 9:45. Is this okay from all of you? So all of you, we take our lecture in above part. We'll take today last two lectures, or the late lecture will to the morning class. So I will remind you the morning time will be the 7:45 to 8:45. Then we have a break. Then from after break from 8:50 to 9:50. So I will also send you the reminder during the morning class, like joining of meeting. One question will whenever you find out the NC, you see here the constant rate period. So constant rate period here, what will be the NC? I take NC from here. So N is equal to 10 raised to 3. So 1 divided by N is equal to 1 divided by 10 raised to minus 3. So 1 divided by N is equal to 10 raised to minus 3. So I take the value of N from here, from this graph here. We'll also calculate more example from tomorrow morning. बोलो सर. आप किसमें ले रहे हो?